oh, you can't see it. Hang on. Quiz. So you guys have finished the quiz so far already, hopefully. And then we're going to kind of take a look at what's going on today. Can you guys all hear me okay? Yes, no? Give me
Yeah.
okay, all right, good. All right, perfect. All right, thank you. So today, these are the handouts you need today. Quiz 7.3 and Notes 8A. Those are the ones we're going to be working with today. We're going to finish up, we're going to do the quiz for 7.3, and then we're actually not going to do this part here. Delete that. And then we're going to do hypothesis tests 8.1 and maybe probably not 8.4. We're just going to do 8.1. You have Connect Math 7174 due tonight. Thursday you have 7.3 due. And then next Tuesday you have Connect Math 8.1 due. Lab Part 5, I'm going to put that off to April 14th because we have plenty of time. I'm going to cut it down to the bare minimum. I need to do 5 labs. So we're doing 1, 2, 3, 5, and 10, and that's all we need to do. That's the minimum I can do, so I'll do that instead. I do want you guys to fill out my office hours survey, so I know which office hours you guys want. And also, if any of you guys still want to pick up handouts, if you want, maybe I'll put a separate section of just the tables that you'll need. Then I can put those on my doorstep in the complex. You won't need most of the handouts for at least a couple of weeks, though. If you went to the review session and you had them, the tables you won't need. The T table. Well, actually, you could use a T table. I can put those out. So let me talk about that just for a minute. I guess this died too. Oh no, it's here. So first of all, under assignments, this is where you turn it in. So you go to our Canvas site and you hit assignments, and these come up. So here, this is where you're going to turn in. If you didn't turn it in yet, turn it in, tonight. The stuff from Chapter 7, you're going to hit Submit Assignment, and then that will allow you to upload these pages, a 7.1 quiz. I really only need the first page, actually, since the second page is really what we did today in our quiz, and then pages 4 and 7 from the Chapter 7 notes. So when you hit Submit Assignment, it will bring up, yep, there we go. It'll let you upload files. So you can browse and upload a picture of your first one, and then add another file, the next one, and add another file to the next one, and then hit Submit Assignment, and that will turn it in. That part, it's your participation points. So you get 4 for being here, and then the other 6 points is for submitting these papers. And then, if you look at announcements, page. If you look at announcements.
So we're going to go over the quiz for 7.1.
No, I went over that. In the 7.3 lecture. Except for the first one, except for the one that we did today. So the last problem with 7.1 is the first problem that we did today. The other 2 I went through in the 7.3 lecture. But if you look at these 2 announcements here under announcements, this first one, I said let me know if you're getting these emails. That has my information of at the bottom, talks about if you want the handouts for Canvas, they're in a white box on my front porch, my address, and my front door is not on the street. It's inside the complex. You have to come drive inside the complex to get to it. This kind of gives you a little bit of directions there. And then the other one will have a link to the doodle poll where I'm kind of polling to see when people want my other office hours. I'm going to do 5 office hours or 5 50-minute office hours online a week, and I want to know when you guys want to have those. So if you fill out the doodle poll, it's in the last, I sent you, it was a couple emails ago. It's when I had the numbers 1, 2, 3, 4, 5, 6. It's number 6. was let me know when you want my office hours. So you click on this one and that'll take you to a poll, and you can just, it's technically for this week, but it's really for all Monday, Wednesday, and all the rest of the weeks of the semester. So if you click on that, that will bring that up, and you can just mark in which times that you think, which times and days work best for you. And it's not coming up, so I'm just going to kill it off because there's no reason to do that. And then the last thing is, if you need the handouts, they are posted online. I'll show you where they are. The T-table is also posted online. It is, oh, son of a gun. I didn't want to go here. It's okay. Everything's really slow when I'm on Zoom. Now we've wasted 20 minutes. Come on. So kind of that first thing you see when you come in has the link to the Zoom lectures and things like that. And then this one down here has the handouts. So these are our notes and quizzes, and then here's the T-table right there. And then if you want to watch the videos, I'm going to post all these on video, and then if you click on this, this will give you the video playlists. So you can link in and watch any of the videos online. So I'm taping yours and the 5 o'clock one, and assuming there are no problems, I'll post both. If one of them has big problems, then I won't post that one. Okay, I think we're done with this, so I'm going to close up that. Oh, close enough. Sure. Okay, so today, we're going to kind of go through this 7.3 quiz, so let's take a look at it. Everything's really slow. Okay, great. So again, just a quick review. We did this actually together last time I saw you guys. We talked about finding the error, right? Because if you remember, let me talk to you guys for a minute. Stop share. Oh. Okay. If you guys remember, our best, am I big? I'm big. I should be big now. If you remember, the whole point of a confidence interval is to guess at what the whole population would be. So how do you do that? You take a sample, because you want to poll the whole country or the whole world. So you you take a sample, and that gives you a best point estimate. It gives you a number, like, I want to know what the average height of all college students is. So I randomly sample a bunch of college students, and I find their average height is 67.3 inches. That's my best point estimate. That's my best one number guess. But it's unlikely that that's the actual number. So I'm going to take a little bit of an interval, a little bit this way, a little bit that way, and say that I think that the actual number is between these two numbers, the actual mean for the whole world. So you're going to take a certain number of standard deviations this way, a certain number of standard deviations that way. And before, it's similar to what we did in Chapter 3, right, where we found the lower and upper usual values. You take your best guess and you go 2 standard deviations this way, 2 standard deviations that way, and you think it's, most usual values are between here. Here we're saying that the mean is probably between these two values. So let's talk a little bit about proportions and means. So a proportion, so our best guess for a proportion would be what we call a p-hat, because proportions are p's. So what's the example of a question that is a proportion question? Not what am I asking you, but if you were a researcher, what would you be asking somebody else? What kind of research question would lead to a proportion? Anybody? What kind of question would I be asking people? Rosie, anyone? Okay, it's a yes-no question. So in other words, I'd be asking something like, did you draw a blue marble or not draw a blue marble? Are you a student? Did you vote in the last election? Things like that. Those are going to be yes-no answers. Can you guys hear everybody okay? Is that feedback too bad? Should I mute those? Okay. So again, yes, no questions, that leads to proportions because either it's going to be a yes or a no, is or isn't. A mean, on the other hand, is going to be what kind of question? What kind of question would I asking people? Adam? What do you think? Someone? Anyone?
What kind of questions do we ask for proportion?
For proportion would be a yes-no question. For a mean, what kind of question would it be? Angela's like,
The question what's your favorite color?
okay, so that, again, I would simplify that down to a, is your favorite color blue or not? And that'd be a yes-no question.
Binomial.
Yeah, right, so that's a proportion. Binomial sort of stuff, that's proportion. But now we're talking about means, because I can't take an average of a bunch of, I can't take the average of red, blue, and green. So what's the amount I can take the average of? What do we average? Age, great. Age is perfect. What's your age? That's numerical, right? So when our data is numerical, then we can have a mean. And that's where these means come from. They come from numerical data. So something like, how old are you? How tall are you? How many classes are you taking? Things like that. So those are where our means come from, our X-bars. Those come from data that's numbers, versus proportions come from data that are yeses and nos, or categories, right? Blue or not blue. I mean, your colors could work, because we could kind of make it blue or not blue, red or not red, that sort of thing. Okay, so now that we sort of sorted out that, and the idea that, again, you take your best guess, which for a proportion, yes, no would be p hat, the proportion of people who said that they are a student. So if I said, Angela, I'm going to mute you if you don't mind, sorry, because there's a lot of feedback. But if I get, if I survey 45 people and 16 of them are students, then 16 out of 45 would be my proportion. My proportion of yeses, the percent of yeses would be my p hat. So that's where this p hat comes from. It's your percent of yeses. Okay, good. And then X bar comes from, again, your average for your mean of your sample. So you take average of your sample. So you take a sample of a bunch of people, you find their average height, that's your X bar. And then we take that X bar, we try to guess at what the whole world would be based upon our sample. All right, maybe I'll just do one more visual where like you go like this much this way, this much this way. We call the amount we jump error. So if I want to jump 1.96 standard deviations in this direction and 1.96 standard deviations in that direction, the amount I jump would be 1.96 times whatever standard deviation is. That's what I'm going to call my error. So error this way, error that way, and that's error is the amount that you're adding and subtracting from your mean to get to your upper and lower limits. Okay, so let's go ahead and go back to what we've got here. And here you can see my error is equal to Z alpha over 2. And remember, Z alpha over 2, I really would like you to think of this as just the critical value, because this whole Z alpha over 2 confuses the heck out of people. It's really just your critical value. That's what this is. My writing, this is terrible with my mouse. So if you think of it that way, it's just the number you get from your table. So if you look at your Chapter 7 notes, the second page, this is your critical value. It's the number of standard deviations you want to go, typically right around 2, but sometimes more or less, depending on your confidence level. So for a 95% confidence level, my critical value is 1.96. For 99% confidence level, my critical value is 2.58. Remember, we usually want to round to 2 decimal places because it causes us less trouble. And is anybody having trouble with audio? If anybody's having trouble getting a signal to work well, like I'm popping in and out or the video's choppy, then you can do what I do, which is I do the video on the computer, but I do the audio on my phone. So if you click on the audio part, and if you click on it, it'll give you these options. I don't know if you guys can see those, but I can pick either the phone call or I can pick the computer audio. And I would not do the computer audio. I do the phone call. You dial into this number, and it gives you the meeting ID and your participant number, and then you can just connect with your phone for the audio portion. That makes life so much easier. It makes things smoother. Okay, so back to this part here. That's how you find the critical value with that table, and you multiply that by, so this is the number of standard deviations you want to go, and this is a standard deviation, square root of p hat q hat over n. Now, what we're looking at is I want a certain error. Like, I want to be sure what percentage of people are going to vote for Biden within 2 percentage points. I want the error to be no more than 2%. So I need to fix my error at 2%, 0.02. If I want my error to be within 2%, I can't control what my critical value is. That's fixed. That's according to that table. I can't control the p hat and q hat because I can't force someone to say yes or no just to make my numbers look better. But I can ask more people. I can change the n, and the larger n I take, the smaller my error gets, because that's the kind of relationship it has. So the bigger the n, the more people I ask, the smaller error I have, which makes sense, right? Because the more people you ask, if you only ask a few people, you're likely to be off. But if you ask a whole bunch of people, you're much less likely to be off. And if I solve this equation for n, that is, I square both sides, multiply both sides by n, and divide both sides by e squared, then I would get this. So for a particular error, then I can find what n is, because I'm given all of these things in the problem. So that's kind of what you did. And this is the actual formula here. You can also do it where you put, well, we'll talk about that in a minute. And if you don't know what p hat and q hat are, you can just use 0.5 for p and q. And you get this down here. But you can substitute them into this formula as well. It doesn't matter. Either way is fine. And don't forget that you cannot sample a portion of a person. You have to sample the whole person. So, so this can't be a decimal. It has to be a whole number. So here I'd have to make it 2.37 would not be enough. I would have to make it, because I need 237.164 people. So I really need to, if I have to have at least this many people, then I can't have this. I need to have 238, because I need to have at least that many. Somebody else is giving me some feedback here. Who's feedbacking? I don't know. Right. If you're doing feedback, go ahead and mute yourself. What was that? All right. Good. We're good. So here's our problem. Does anyone want to share theirs? Just unmute and let me know if you're willing to share, and then I will pop off and let you screen share and you can show your work. Adam, are you saying you want to share? No? No. Anybody else? You guys want me to do it? Okay, I'll do it. That's fine. No problem.
I got you on the second one, though.
Okay. Sounds good. Awesome. All right, so I'll to the chat. Maybe I should put my chat in and see if somebody's saying something. Let me know if someone comments there. All right, so here, researcher wishes to be 95% confident that her estimate is how we know it's a confidence interval. Anytime you have a problem that says estimate or confidence interval, that means, estimate means find the confidence interval. So this is a confidence interval problem, 95%, which means that my critical value is going to be, well, I don't know, let me look it up in my table. Look it up in my table, 95% confidence interval. My critical value is 1.96. Swell. Okay, so we have that. So we know that our critical value is CV equals 1.96. Great. And then we say for individuals who travel overseas is within 2%. So you find within and you find your error. Remember, if I'm asking you what the sample size should be, I have to give you the error. I can't give you just parts of it. So here is my error. So my E is equal to, I'll use black, I guess. My error is equal to 4%. How do I write it as a decimal? 0.04. And then we've got the sample size necessary if in a prior study. So my prior study had, not my study, but a prior study had 200 people with 40 of them who traveled overseas. So that's 200. That's my p-hat. Prior study was 40 out of 200. Oops, that's kind of terrible. Ooh, that's really bad. 40 over 200. So if I have 40 over 200, that's 0.2. If my p-hat is 20%, in other words, if my yeses are 20%, then my no's, what percent of no's do I have? Q-hat must be what?
80% or 0.8.
Exactly, 80% of 0.8. Yep, because these have to add up to 100%. If 20% say no, 80% must have said yes. Good, so now I think I have all the pieces I need. Let's go ahead and take a look at this. So going with our formula, n is equal to, n is equal to, and you can do it also this way. We talked about that before, where you put the critical value, this is how the book does it, over E squared times p-hat, q-hat. Or you can do it the way that we did it in class, which is kind of the way in the last form. Either way, you get the same thing. On top, you're going to get, here you might get 1.96 squared. I can't do a squared. Darn it. It doesn't really help me. Sure. And then divided by, try this way, 0.04 squared times 0.2 times 0.8. Sorry. Actually not any better. Okay. So what did you guys get for this one? Anybody? 300 and, was it?
385.
385. Great. So you end up with 384.2 or something like that. And again, you can't have 0.2 per person, so you have to round that up to 385. Now, the second part is if you don't have any estimate of the sample proportion, so then you're going to use p-hat and q-hat equal to 0.5. So here you'd have p-hat equals 0.5 and q-hat equals 0.5. So in this case, you'd end up with something along the lines of n equals, I can try this, 1.96 raised to the second power times 0.2 times 0.8. Oh, sorry, 0.5 times 0.5. And the bottom part would be 0.04 squared. So now I just need to move these guys around. Draw a line. Square that. And square that. And what did you guys end up getting there? Anybody? Help me out. 600.25?
Yeah, 601.
Right. Perfect. So 600.25, which again, you can't have 0.25 per person, and you need to have at least that many, so you have to round it up to 601. Good. Okay. Perfect. So that's that part. Let's go ahead and take a look at this next one. So now we're going to talk about, you know what, I'm going to pause this for a second. Someone go ahead and let me get